Welcome to this web lecture about data entry, which is mostly done through keyboards. We will start the explanation of the importance of keyboard design by means of a video where I am using the piano. Let's assume we have to play the following 10 notes. Now, depending on the keyboard design, this is like typing 8 letters, it could be arranged so that it is indeed like, or we could change the keyboard design, and this is what QWERTY keyboards are like, so that we have to alternate between our hands. With the QWERTY keyboard design, I will now try to play as fast as I can these 10 notes. I can tell you it requires some skill to do this. Yet, with or without skill, if the layout is such that we first play 5 notes with the left hand and then with the right hand, we can always do it faster. So the keyboard layout and its relation to the language that we have to type determines whether typing will be efficient or not. The QWERTY keyboard layout that most of us are used to already dates back to 1870, when early typewriters were being designed. It's a clever mechanical design that tries to avoid the hammers of the typewriter from jamming. The idea is, when you put frequently used letters far apart, then it will slow down the typing, as we saw in the video of me playing the piano, and it also makes sure that hammers that are used one after the other come from opposite sides of the typewriter. Clever design, but inefficient. For computer keyboards, we need to look at a better design. And in fact, this has already been done by Mr. Dvorak, who came out with this alternative layout that actually reduces finger travel distances, so you can type much faster. Yet, the acceptance of this alternative has been slow because people are always resistant to change. It is a bit strange in this case because it only takes about 1 week of typing to actually become fluent, in typing on the Dvorak keyboard. When I made the switch on the accordion from a piano keyboard to a button keyboard, it took several years to reach the same level I had before. On a keyboard, it only takes 1 week, yet resistance to change is really strong in humans, and this keyboard is still not popular. There's another alternative design for people who normally don't type at all, and it is this simple alphabetical order. Since everyone knows the alphabet, people will not have a lot of trouble to find out where which key is located. We see this type of keyboard sometimes in terminals inside bank offices, where people have to do their banking, and often everyone who doesn't do it at home with internet banking is probably not used to type on a computer, and so this is a good alternative. There are many other aspects about keyboards that influence acceptance or resistance. The IBM PC keyboard was criticized just because of the placement of a few keys. Like in between the letters on the lowest row of keys and the shift key, there is the backslash key. And this backslash key is sort of in the way to quickly switch from shift to the letters, by people who are used to typing on a typewriter that doesn't have this additional key. Also, on the IBM PC keyboard, there are special characters in between the letters and the enter key. And that, again, makes it a bit harder to learn. And there's also the shape of the enter key,
which is different on a US keyboard than on a Dutch keyboard, even though both keyboards are QWERTY. So whenever I buy a computer, I have to order the US keyboard specifically because that is what I'm used to. The number pad layout is also a problem that cannot really be solved. It can only have one layout, and we already know that the layout of the number pad keyboard is different on a phone than on a calculator. Which one should the computer replicate? There isn't a single answer that is right for everyone. Also, the wrist and the hand placement with keyboards is important to avoid repetitive strain injury after extended use. The keys themselves have to satisfy a lot of properties that are all very important to have the most comfortable experience. We have so many different keyboards nowadays, larger and smaller, that they all have different properties and that makes them harder to use. A standard keyboard has half-inch square keys, and at the top they are 1/4 inch spaced apart. They have a concave surface and a matte finish. That sort of makes the keyboard feel right. On most laptop computers, we don't have that anymore, right? And it takes a bit of getting used, right? I tend to still use a separate keyboard because I really want the keys to be like this. Right? The force to activate the keys is also, and there is a fairly large range, right? But nowadays we are typing on phones, for instance, where there is actually no displacement and no force. Right? The optimal displacement is at least 3 millimeters. We should also get some feedback. You should feel you're pressing a key. And on a phone, this is replicated through vibration. Right? And we should hear the click of the key. That again can be artificially reproduced. Some keys have different measures, Enter, Shift, Control. Some keys also have an indicator, like you need to see whether caps lock is on or off. On the old typewriter, this was visible because the caps lock key stayed pressed. Right? Its physical position indicated whether caps lock was on or off. Right? We need a visual indication, for instance, with a light. Function keys and other keys need to have large, meaningful, permanent labels. For the letters, this is clear. For function keys, it is not. When we have function keys, it can actually be speeding our work up in good ways and in bad ways. Sometimes function keys are programmable. I used to have an old computer terminal at work where you could program strings in the function keys. And so what we did was we turned on the terminal and the first prompt said, which computer do you want to connect to? And so we put that string under F1. And then the next prompt was the login prompt from the computer. What's your username? And we press F2. And the next prompt is password, and we press F3. Obviously, we never told management that we were doing this or we would get fired. Most function keys are labeled with sort of anonymous labels, F1, F2, F3, right, that have no meaning. You can perhaps replace them, right, or overwrite them with meaningful labels, but you have to normally remember each key's function because it is different for every application, and it's different also on different platforms. It's quite annoying. Right? I use, for instance, PowerPoint. I use that on a Macintosh and on a PC. And even simple operations like start a slideshow require different keystrokes on one platform versus the other. So for all these function keys, you have to remember which has which function. The placement on the keyboard is also important. On older keyboards, the function keys were all placed on the left, which means you have to move your hand away from the letters to the function keys. and that costs time. It reduces the efficiency. There can be lights to indicate whether a function key is actually available. Right? Some functions may not always have meaning in a given application. And when there are not enough function keys, people have resorted to using combinations with Control, with Alt, with Command, and we have so many shortcuts nowadays that nobody can remember what they all are. For cursor movement, we typically use the inverted T placement of arrow keys. We have up, down, left, and right, and we need a good placement for these. Sometimes we may want diagonals, but no keyboards that we use nowadays have those. The best layout is some natural position. But in some old systems, we used 4 letters, H, J, K, L, which are next to each other on the QWERTY keyboard, and then it isn't natural which of J and K is up and which is down. The inverted T makes that easy to recognize, and sometimes you also see a true cross arrangement where the up and down key are spaced a little bit towards the center of left and right. Most applications give these cursor movement keys an auto-repeat function so that we can move more quickly over the screen. And function keys can also be used, and cursor movement keys, for switching between fields on a form, so that we can use, for instance, the down key to each time move to the next field down. That may be easier than using Tab and Enter and Home keys. Tab is a very common key for also switching between form elements. The Enter key is a little bit uncomfortable because in some applications it means submit the form, and in other applications it just means move to the next field. So if you're unsure, right, you will tend to not use it for the function it's designed for because you don't know which one that is. On very small devices, we've seen lots of attempts to create usable tiny keyboards. The 3 we see on the left require essentially a kind of a pen to use because the keys of this normal QWERTY or AZERTY or other layout keyboard, they've become really too small. What we see nowadays more is the use of virtual keyboards on phones. Small keyboards, they are sometimes wireless, so they're separate from the device. We see that a lot on tablets nowadays. We also have the virtual keyboards on the screen. We can have cloth keyboards or optical keyboards, some with soft keys, right? But what we see mostly now is the touch screens, right, with the virtual keyboard and some feedback through vibration and sounds. There are completely alternative ways to enter data. What we see in this image, for instance, is the OrbiTouch keyboard, which uses inverted bowls, right, where small hand movements and a little bit of finger movement is enough, right, to actually enter different letters. Supposedly, this is better for people who are prone to developing RSI. There are completely different alternatives, like what we see here, to enter text by sort of moving with the mouse to make selections between suggestions. This type of input, but not in this graphical way, we also get when we use mobile devices nowadays. You start typing words and you get some suggestions, and you can immediately select from the selected words instead of continuing to type. The other and final text entry method that I want to discuss here is writing. Now, recognizing all different people's handwriting is computationally difficult. And so what we saw on older devices, like the Palm Pilot, a precursor of the iPhone without phone functionality, and without any connectivity initially as well, instead of teaching the device to recognize your handwriting, it had a predefined handwriting, and the human user had to learn to adapt to the device. This is a very typical example of how not to do human-technology interaction. We do not want the users to adapt to the technology that has been implemented. We want to adapt our technology to what the humans really want. So this type of design we do not want to repeat in the future. Thank you for participating.